Unit 4, Section 3, Implications. Section Objectives. By the end of this session, the student will be able to draw implications from statements. Implications. For any two statements P and Q, P implies Q means Q is true only when P is true. Let's consider these two statements. Statement P, Asari is a Ghanaian. Statement Q, Asari is an African. And from these two statements, we see that if P is true, meaning if Asari is Ghanaian, then Asari is an African because Ghana is in Africa. Now we see that whenever P is true, Q is also true. Now when these two statements are combined by if, then we have the third statement which reads, if Asari is a Ghanaian, then he is an African. This combined statement is what we call implication. Now we say that P implies Q, which is written as P, the implication sign Q. Now the statement R then is Asari is a Ghanaian implies Asari is an African. Also, the statement, let's say P, Abena has muscles, and statement Q, Abena is in the hospital. From these two statements, if P implies Q, meaning Abena is in the hospital because she has muscles. So P implies Q. The implication symbol is what is used to connect implications. Now let's note that the converse of the statement R, which is the combine of P and Q, is not true. This is not true because when Q implies P, it means if Asari is an African, then Asari is a Ghanaian. But the fact is Asari is an African does not mean Asari is a Ghanaian. Asari may belong to any other country, and hence that statement, it is not true. And also mathematically, let's consider these two statements. X squared minus 1 is equal to 0. That is statement P. And statement Q, which is x is equal to plus or minus 1. Now, if P implies Q, then it implies P is true when x is -1 or +1. Now, its converse, Q implies P, is also true, since if we substitute x is equal to 1 or -1 into x squared minus 1 is equal to 0, it gives 0. And this means that P implies Q and Q implies P. Implications. If P and Q are two statements such that P implies Q is true, and the converse Q implies P is also true, then we connect P and Q by using the equivalence sign, which is read as P if and only if. That is, P is only true if and only if Q is true. Example. Expressed in English, the statement P implies Q. Where P, that is the statement P, it is raining today. The statement Q, 2 plus 3 is greater than 4. Now, using the implication, if then the statement becomes, if it is raining today, then 2 plus 3 is greater than 4. Implications. Example 2. We are to write the following statement symbolically. You write the converse symbolically, and you find the true value of this statement. For us to do this, we first have to let P be the statement 1 is less than 2, and Q be the statement 3 is less than 6. Now, from the given statements, we can write symbolically as P implies Q. And for implication, P implies Q is true, except if the first statement is true and the second statement is false. But since both statements, 1 is less than 2, is true, and Q, that is 3 is less than 6, is also true, we conclude that the statement is true. Now the converse may be written as Q implies P. And in the white form, if 3 is less than 6, then 1 is less than 2. Now 3 is less than 6 is true. 1 is less than 2 is also true. And since both statements are true, we conclude that its converse is also true. Implications. We look at the question number B from the previous slide. The first statement is P, that is 1 is greater than 2. And the second statement Q, that is 3 is less than 6. Now writing this symbolically means we write P implies Q. Now for us to determine if P implies Q is true or false, 1 is greater than 2 is false, and 3 less than 6 is true. Since the first statement is false and the second statement is true, we conclude that P implies Q is true. In the word form, we can write this as if 1 is greater than 2, then 3 is less than 6. Now the converse may be written as Q implies P. That is, if 3 is less than 6, then 1 is greater than 2. Now we want to find if this statement is true or false. 3 is less than 6, meaning the statement is true. But 1 is not greater than 2, meaning the statement is false. But for implication, if the first statement is true and the second statement is false, then we conclude that the combined statement is false. Hence, the statement is false.